Morning, everyone. So, and what was our last lesson? Decision under uncertainty, and then did we start with the decision under risk? Not yet. Okay. Today we discuss about. Can you see my slide? So, what we have here, we discussed about risk and uncertainty, and what's the difference between uncertainty and decision under risk, right? Then, basically, we discussed about expected value and then decision tree and risk analysis. Okay. So last time we discussed under this topic, decision under risk, right? So last time we discussed about decision under certainty and uncertainty. Today we discuss decision under risk. Later on, okay, after this we'll discuss about decision under utility group decision theory, and then decision under conflict with this theory. This is the topic for today. Right. So what is the difference between risk and uncertainty? Okay. So uncertainty refers to not knowing what will happen in the future, okay, or little or no available data, or because it's very expensive or time consuming to get the data, then you will not have even probability information. Okay. So decision under risk is similar to decision under uncertainty, okay, but you have good probability information. So you have learned statistics, right? Correct. So how do you calculate probability? How do you get probability? So there are many methods to get probability. Okay. Can you see my whiteboard? No? Yes or no?
Yes, sir.
Yes? Yeah, so there are, to calculate probability, okay, there are many methods. Okay. At least four methods. Okay. So one is you assume certain knowledge about the phenomenon. Okay. Usually we assume uniform distribution. Okay. Distribution. So for example, okay, tossing a coin, right? And then you will say, okay, if I toss a coin, the probability is 0.5. So that's assuming a uniform probability distribution, right? Similarly, if you toss a dice, okay, then you will say, oh, the probability is 1/6, right? For each face. So that is assuming uniform distribution. Okay. Second is based on the data. Okay. So this one, probability basically the same as frequency relative. Right? And the third one is based on theoretical distribution. Okay. And the last one is called based on opinion. So this is based probability. Now, my question to you, I guess you have learned all of these, or some of these you did not learn. You tell me which one. I'm sure the first one you learned is on this in high school, right? The close of point is half. The close of a dice is once of a six, right? And then believe you also learned that probability you can get from the data based on frequency relative. Is that correct? And then you have learned also in statistics many different distribution. For example, binomial or Poisson or normal distribution. So, right. And then we have also probability based on opinion that we can revise based on the fact. So this is based on base theory. So is this okay, or you want to go more detail? Up to your first. If you don't understand something about this, you tell me. I can go more detail about each of this. I believe this has been taught in statistics. Not you tell me, I can give you. Okay. So let's come back to the decision analysis. So we assume that you have good probability information. That means you can either get it from the assumption of uniform probability distribution, or some theoretical probability distribution, or some data, or some based on the opinion, based theory. Now, we also learned last meeting about decision under uncertainty, right? So this is a review. So basically, this is a single person decision making problem. Okay? The probability distribution of the state of nature is unknown, okay? And the decisions are based on criterion. These are the criterion: maxima, minimum, maximum, Laplace, okay? Hurwitz, and Savage, right? Minimum regret. And then it can range from positive or optimistic to negative. This is pessimistic, or somewhere in between, and based on gain or cost build matrix. Now, when we discuss decision under race, okay, this is exactly the same with the single person decision making problem. That means you against the nature. Okay. And next, the only difference with the decision under uncertainty is this, okay, that the probability distribution of the occurrence of each state of nature is known. So again, I put this note here as subjective probability. So if you don't know, you can just assume based on your opinion. So this is based on the bias theory, right? So decision criterion of decision under risk is usually based on expected value. Okay. And then the probability of occurrence of its state of nature are the same for all alternatives. So in the decision table, in the payoff matrix, in the column you have here like this. In the column you have state of nature, right? And then for each state of nature, you have some probability information. Okay. But for each alternative, we assume the probability of state of nature are the same. So there is no different for all the alternative, okay, using payoff matrix. But if we use later on using decision tree, okay, then this probability for each state of nature can be different for each state of nature and for its alternative. Okay, so the technique to compute is just simple expected value. That means you calculate the mean, the arithmetic mean. So the approach to select the decision alternative that is based on expected value, okay, for each decision alternative. So we said we want to get the best expected value. But what is the meaning of the best? The best depends on your data. Okay, it is either gain or cost, right? If it is gain payoff, okay, then of course the best means maximizing the expected value. Okay, so if it is cost, right? So you are minimizing the expected value. I think that's logical. So important here is for each alternative, okay, they must be uncorrelated. So try to create what is called mutually exclusive and exhaustive. Mutually exclusive means uncorrelated. Right? One alternative and the other, there is no overlapping. Okay? And then exhaustive means all possible alternative that you can put. Okay. Now, here is the formula. So if gain, right? So JK is basically the gain payoff. So you multiply by the probability, okay, and then you sum for all the K. K here is what? State of nature. Remember, J, JK, that means J is the alternative, K is the state of nature. The column is the state of nature, right? So usually row and column. JK is a row column. Okay, and then PK here means that is the probability of the column. It is the state of nature. And we get the expected value, which is the mean. Okay. And then what we have. So when we get the gain for each J, okay, J is the alternative. So you get the maximum, the mark means the argument of the maximum of this average gain. Okay. So we call this J star. Similarly, if you put the cost, you do the same thing, but you get the minimum. Yeah? Okay, let's practice. Yeah? So this is exactly the same example like decision under uncertainty. So you can open your Excel and then input all of these numbers, and then what you will do, you get the expected value. Okay, this is payoff gain. So how do you get the expected value? You just multiply. Just multiply the payoff with the probability. Okay. Let's do the practice. I will open Excel. Okay, so let's copy that. There, I can copy this. Let's remove all the formatting. Clear all format. Then just auto fill. Okay. So this is our table. This is the input. This is another input. So I put yellow. Right. So what you will do, because this is gain, right? So you will maximize, right? You will take the maximum. So I will put the expected value, EMV. It is some product, right? Some product of the probability and the payload, right? It is the probability does not change. The row will not change, so I will just put 4 with the dollar sign. The rest can change. Copy here, and then we want to get the maximum, right? So the maximum is max of all of this. So when this happen, oh, this is the arc mark. So you get the when this happen 6.6. So we will do matching. Okay, we will do matching between this value and that, right? Array. So you get the to be exact. Okay, so I get number 1, right? That means index. This happened because this is number 1. So then I will get the alternative name. Huh? So the alternative name, how do you get the alternative name? Index, right? Of what? The array. And then the row is this one. Huh? So this is the decision. Here, can make it. So with this, what you will do, if you want to change, for example, oh, I have different values here, not 5. This is 4, okay? And this is probably 2, and this is probably 1, okay? And this is probably 0, and this is 2 and 1, and this is 15. Oh, decision will change accordingly based on your data. So you only need to change the data, which is in yellow, right? But the decision is automatically computed. This is the row position. So it's clear, easy. You can make it, right? So if this is cost, what you will do, you just change this. Huh? Become instead of maximum, you just change it to minimum. The rest is the same. Is there any question? You can do it. Or you want to practice? Okay, fine. That is the maximum. Okay. So now you need to get the decision. So you get one more column. So for example, in column G or H, okay, when that 6.6 happened, so I believe we have learned about index and match function in spreadsheet last semester. Do you still remember? So you can use it.
What we want to get, sir?
We want to get the argument of the maximum. So how do you get the argmax? There's no function argmax in Excel, right? Okay, so you can use max. Max will give you the relative position. So that one maximum, comma, the lookup array is the EMV.
Oh.
The EMV.
Yeah.
Yes. And then match type is exact. Very good. Yes. So you see that you get the one exactly. And then you need to get the alternative, right? It is A, B, or C. Okay. So in that case, you put in column H. So equal index.
Equal
Index. Index of the array, which is A, B, C, the alternative. And then the row is the column G, the row position. Very good. So you get A. Now with this, this is the decision. Column H is the decision, not the alternative. Column H here is the decision that you will get. Okay. So I will put the probability as yellow, and then all this payoff value as another yellow, so that I can know that this is the input, and probably the alternative result will be different color. Okay. Okay, very good, Liffy. So how about you, Joy?
Yeah, I was able to get the same results.
You want to share it?
Wait, give me a moment.
So you can add one more in column G. That one equal index of the column A. It is and then that one is equal to match. No, match. M-A-T. M-A-T.
I can't hear you quite well, sir.
Matching. Match.
Okay.
Okay, there. So matching depends on the value, okay, and then the EMV, match of the EMV, comma, the EMV, comma again, 0. 0 is mean exact. 0. Okay, close. Yeah, very good. Yes. Okay. Okay, very good. Yeah. So let's go back to the slide that we discussed a while ago. So we have practiced this, right? So you get the, now you can compare with Laplace criterion, okay? How do you compare? you just change this probability value become equal, right? So if you change that probability value become equal, so equal to 1/3, what will happen? Okay, equal to 1/3, equal to 1/3 for the probability. So what will be
Sir,
the,
you still sharing the PPT.
yeah, okay. So you try to
Okay.
change the probability value to 1/3 for in your case. Can you share?
For all of the.
Yes, because the total probability must be 1, right?
Yeah.
Yeah. So only that 0.5 now you change to 1/3. So equal
Okay.
1 divided by 3. Okay, very good. And then C also the same, copy. Right. Oh, the decision still the same, eh? A.
Hmm.
Right. So it doesn't change in this case. Okay. In this case, it doesn't change. Okay. So, but basically you can always change this probability value or the payoff matrix, okay, as long as they have the same size,
Hmm.
right? And then you will get, so this is practically a simple program already for you. Okay. So,
Sir,
yes, please.
is this decision under risk?
Correct.
Oh, we covered this last week until it's finished.
Oh, it's already finished?
So now it's supposed to be, yeah, we finished this one.
Okay, so you
I
learn
just
about this.
realized.
Okay. So, how about the fruit problem? You already finished also. This is the decision tree.
Yeah.
Okay,
We did.
very good, very good. Okay, we did. Okay, then we continue with the next topic then. Thank you. So let's review. This is the, once you get the decision tree, okay, and now you can do what is called risk analysis. Okay, so risk analysis is the study of possible payoff and probabilities associated with the decision alternative or decision strategy. Okay, what's the difference between decision alternative and decision strategy? Okay, decision alternative is just one alternative. Yeah, decision strategy is if you have a sequence of alternative decision. Okay, so let's study about this. Okay. So risk profile, okay, is a chart. So when we say risk profile, it's basically a chart that show the probability distribution, okay, of the possible payoff associated with decision alternative. In your case, a while ago, how much is the value? Decision analysis under risk a while ago, 0.5 and then 0.5, 0.2 and 0.3, correct? In your example, yes. So that one, now you can put N1, N2, N3, and then you can start to chart. Okay. That will become the risk profile. Okay. Now for the fruit problem, okay, we can use this to check. Yeah, what is the purpose of risk profile? We can use this to check. Okay, to compare the change in the distribution. Okay, and we can check the change in the distribution of the risk, okay, after you do decision analysis with this optimum. Okay, so let's say this is an example. Last time we discussed about fruit problem. You still remember? Last week. So we have a big order or small order. We have high demand or low demand, right? And then if you have a big order and high demand with probability of 0.6, your payoff is 100. Okay. If you have big order and low demand with probability of 0.4, your payoff is minus 100. Okay. So now we can check this gain. Okay. And the optimum decision is the one in black, yeah, very thick black here, big order with this. This is your decision alternative, right? So then you check in this big order, what is the probability distribution? Okay, in that case, you have a probability of 0.4 and 0.6. Okay, and then what is the gain in that case? Oh, 0.6 is associated with 100. Okay, 0.4 is associated with negative 100. So what do you think about this? Do I jump or you can follow up to here? Devi, Joy, tell me.
I don't know, sir. I think we haven't reached this problem. If I'm not mistaken, we only discuss about the uncertainty, not under risk. Wait.
Oh, we did do the fruit problem where and the order thing, right? This one we don't do the risk profile, but we actually do
Yeah.
this problem. Yeah.
Exactly. So we did the risk profile, right? We did the under risk. Is that correct? Where is the decision under risk? Oh, there. Yeah, I will resume again so that you will not get confused. Okay, so last time we discussed about decision tree, right? And then we have what is called decision strategy, yeah, it involves sequence of decision. And then we have decision tree, which is a tree diagram, okay, which has three nodes, right? Three type of node, which is decision node, chance node, and leaf node, okay? And then we have an example of fruit problem. I hope you still remember this. Okay, and this is the problem of fruit problem. Okay, and then this is the decision tree. Oh, I remember last meeting you try this, right, to convert from a decision tree to payoff matrix. Yeah, and then probably you did not discuss about how to compute in decision tree. Is it correct? Did you try to compute in decision tree? No, you don't remember. Okay, so let's say you have this problem. Can you calculate it as decision tree? Can you make it into decision tree? And then can you calculate? Is it possible? So, okay, the step is like this, okay? First, you compute the EV for each leaf. Okay, and then you compute the EV for the chance node, and then you compute the EV for the decision node. Okay, for the chance node. Okay, let's take the example here. So this is your payoff matrix, and then from the payoff matrix, can you make the decision tree? Easy, right? Okay, so what is the alternative? Okay, with this big order and small order. Okay, so the blue here represent the decision node. And then for each alternative, okay, you put the node, yellow node here represent the chance node. So in the chance node, you have high demand or low demand. Okay, at the end, you have the payoff, which is 100 minus 100 and so on. So from payoff matrix to the decision tree, do you have question? Can you make it? Joy? Leafy disappear.
Yeah, we made it last week.
Oh, you made it last
The
week.
decision tree. Yeah, wait, I'll check again.
Okay, so you can calculate the EV for this and so on, right? And then you can identify the best decision, correct? Is that correct?
Yes, yes, we make this one.
Okay, we make this one next week. Okay, then. So then today we will continue that, okay? So we continue that with calculating the risk profile, right? So this is exactly the same like last week, okay? What we do is only this. We add the chart, okay, of the optimum decision, okay? What is the optimum decision? Last week is big order, right? So in that case, the optimum decision big order, what is the distribution of that big order? High demand 0.6, low demand 0.4. So in that case, you can put the value, okay? Which is 0.4 is associated with negative 100 and 0.6 is associated with positive 100. Do you get it or not? So I cannot see you, so you need to tell me.
Yes, sir, no problem. Yeah.
So this happened without study. Okay, this happened without study. Okay, suppose, for example, we said, look, based on market study, okay, based on market study, we know, okay, that if the probability of high demand is 0.6 a while ago, okay, and low demand is 0.4 a while ago, right? So, but the market study can be correct or incorrect. Okay, so if then we ask now, this is a sequential decision, okay? So now if we know that the market study is correct, that probability, okay, of correct market study, okay, and have high demand, that is 0.9, okay? And then the probability that the market study is incorrect and there is high demand is only 0.1, only 10%. How about low demand? Okay, the probability that the market study is correct and there is low demand is 20%. This is given, yeah. And then the probability that the market study is incorrect, okay, given this is low demand, is 80%. So this 0.9, 0.1, 0.2, 0.8 here are given. Okay. So then we can start to compute, okay, what is called joint probability, right? So we can compute what is the value of correct market study and high demand, and so on. Okay, and from there we can also compute the posterior probability. Okay, now based on those two, okay, we can check now. A while ago, when we have no market study, okay, the maximum is 20, right? This one, based on the decision and the risk. So now we can check if based on market study, okay.
Sir, your slide is still in the EMV, the the cutting where we, yeah.
This one,
It's back. Okay.
can you see it?
Yes, yes.
Yes, yes. Okay. So now, if you know the market study, okay, a while ago, the one that decision under risk a while ago, it has no study, right? So you have a maximum of 20 with big order or small order. Okay. Now if you do certain market study and you know the market study can be correct or incorrect, right? So now you have a sequential decision here. Okay. It's not just a simple decision. Now you have a strategic of decision. Say, in this case, you also compute the same thing, okay, for all of this. And now you can compute the EV. Okay. If the market study is correct, of course, you will choose big order. And if the market study is incorrect, you will choose small order. Okay. Now, based on that, now you will see, okay, the risk profile will be totally different. Okay, because now you have a market study. Okay, if you choose between the two, you will see the market study is either correct or incorrect, right? If it is correct, you choose big order. If it's incorrect, you will choose small order. And then you check the probability there, and then you can start to draw the risk profile for the optimum decision. Okay, so the optimum decision for correct is big order with the probability of 0.8 and associated with 100, right? Low demand is 0.13 associated with negative 100, right? If market study is incorrect, associated with the small order, right? That will have a certain probability and certain payoff. So all of this value, you can start to chart into this new risk profile of the market study. Okay. Now, after that, you can also do what is called sensitivity analysis. Okay. What is sensitivity analysis? It's a study of how the change on probability, okay, assessment for the state of nature of the N or the change in the payoff will affect the recommendation decision alternative. Okay. So now the technique is rather simple. Okay. You just treat one of the probabilities of the state of nature as a parameter. Then you know that the total probability must be 1, right? Then you can calculate the expected value in the term of this parameter. Okay. And then you can get the range of probability for each alternative, okay, that by maximizing the expected value. Okay. So here, for example, you have the for the fruit problem, okay, you can copy the probability of high demand, okay, the EV and the EV high order and low order, right? And then you can set the probability of high demand from 0 to 1, say with certain increments, say 0.1, okay? And then you highlight the table, and then you can use data what if analysis, and then you can do data table. Okay, so if you can already do this, then you can start to compute. Okay, let's do that in Excel. Okay. I will share with you Excel. And what's the value? Can you see my Excel? Now, we know that the sum of probability must be 1, right? Sum of these two must be 1, right? So now I will treat this 0.6 here as a parameter, okay? So if this is the parameter, right, then this one must be 1 minus this parameter. Okay. So for example, if I change this into 0.5, this will become 0.5 automatically. So if I change this 0.1, the probability of the low demand will change to 0.9. Okay. So then you want to know, you want to get the sensitivity analysis, right? So now we copy, okay, high demand, EV, high order, and EV, low order. So let me get the EV. Okay. How do you calculate the EV again? Sum product, right? Sum product. This one, comma. Okay, and then what is the decision alternative? We make it. It is the same as index, right? Index of this array, right? And then what? The row is based on matching. Matching of what? Oh, wait, I need to max. The max EV, max of the two. Okay, I will get the row position here. It is matching of this maximum value with this EV, comma 0, right? Okay, and then decision is just the index, right, of this array, comma this row position. Oh, but the decision. Okay. So now to create the sensitivity analysis, okay, I will copy this probability of high demand. Okay, probability of high demand, and then I will put the AV of high order and low order. Okay, so this one. So this one is the EV So this is the EV of high order. And then this one is the EV of low order. What is the probability? I just copied it, right? What is the EV of high order? EV of high order, a big order. EV of low order is this, correct? And then decision. Decision. Okay, so say originally this one is supposed to be 0.6. Okay, so then you will put 0.1. Say this one was 0.1 or 0.05 until 1. Okay, so then you highlight the table and then you use data table. Okay, column input to the cell with the P of high demand. So you highlight everything, okay, and then you go to what if analysis data table. Right? In the column input cell, put this one, and click OK. Then you just start. You get the result. Okay. Click here. Correct. It is easy. So it will become big order, start to become big order when the probability of high demand is about 0.55. Right? You can see will become a big order when they become the probability is actually 0. You make it.
Okay,
Then question.
no, but we can try.
Okay, you can. So you share your screen.
Wait, okay, wait, give me a moment. So I used the what if analysis, but it didn't change.
Really? It didn't change because what is A4? Can I see what is A4 in your case?
No, it's
No, A4, A4.
I didn't input
Oh,
anything.
because you put 0.6, that's why.
Oh yeah, okay.
You need to go to the, where is your formula?
I moved from Sheets to Excel.
Okay. This data table can only work if you have a formula that actually compute all these, and then the data table is just expand that formula into various value.
Okay, wait, give me a moment.
Okay. So in that case, you really need to compute that EV and max EV, and then the decision like a while ago. So share your screen once you finish. Okay. So first you create this decision, and then you put the first row in the data table. It is just copy of that decision while ago. So this is just the probability. Okay. So this is just the equivalent, the EV of high order or big order. And then this is the EV of small order. Okay. And then this is the decision with this K.
Sorry, can you share your screen?
Is it
You're
now?
not sharing your screen. Yeah.
I must be very sleepy. Okay, so can you see it now?
Yes.
Yes, yes. So again, yeah, so the step is simple. First, you make this decision table using formulas, right? So you get the EV, you get the maximum EV, and then you get the row position, and then the decision. The row position is based on matching, decision is based on index. The this is the usual things that you already did. Okay, the only difference is actually here in the probability. Okay, so because you want to set this as parameter, right? So in that case, the others must based on that parameter. That's the key to create sensitivity analysis. One of them must be the parameter, and then the others follow that. So if you have three, then the others follow that. Okay. Then after that parameter now you set as the first column in your data table. Okay. And then you create just copy all of this EV, and decision. After that, you just do highlight this, and then data, what if analysis, data table, right? Then in the column, what is the parameter? Of course, the parameter is the probability of high demand, right? So this one. Okay, and then we click OK. Once you make this, then you can plot. So this is the plot. Okay. Okay, try first. Once you finish, you share your screen so that we can proceed in the next topic. Okay. Decision analysis.
Sir, I'll share my screen.
Okay, go. Oh, very good. Right. It start to change. Super, sir. Very good. Excellent. Livy, can you share your screen?
Okay, sir.
Wow. Super. Excellent.
For the graphic, what would
Oh, the
we use?
graphic you just saw or column KLM. KLM, yeah, and then you just put scatter plot. The scatter plot.
Scatter.
Down. Yeah, that. Yes. Oh, you got it. Yes. Okay.
Okay.
Okay. You can start from so that you can see that this is actually big order, small order. Anyway, you can just improve that charting so that it will give you the name, right? Okay, excellent. Wow. You did it, okay? You did the sensitivity analysis for the risk, right? Okay, so what's next? Next is about risk itself, okay? So in finance, okay, risk is measured by these three, okay? One is called standard deviation, okay? And sometimes we use standard deviation divided by mean, okay? Or the other way around, okay? Mean divided by standard deviation. So in finance, they don't use the actual profile, okay, or the probability, but they use another way, okay, with this standard deviation or standard deviation divided by mean, or mean divided by standard deviation. Yeah. Okay. So there's a problem with this EV approach. Okay. So what is the problem? Risk is higher if the probability to win is small, right? But the gain is actually big. So for example, in lottery, right? So you know that the probability to win in lottery is very small, right? But why people still buy lottery? Is there any lottery in Indonesia? In Indonesia, maybe illegal, so people don't buy. Yeah? But in other countries, lottery is legal and it's actually run by the government. So and people still buy lottery even though they know that this is risky. So so to overcome this problem of EV, okay, we have another technique which is actually opening a new way of thinking. Okay, which is called decision under utility, which is the next topic. Okay, so for the decision under risk, is there any question? My question to you. Joy, TV, is there any question for the decision under?
No, sir. Okay.
Everything fine, okay? Good. So let's go to the next topic then. You can follow this in Lentera. We have utility theory, okay? Utility theory is really very deep. And actually the whole micro and macroeconomic, if you study business, right? So this is based on utility theory. Okay, this is like the foundation. But what I explain here is like the surface and just introduce you to what is utility theory for decision analysis. Okay. So let's do this topic. Okay. First is about gambles. Okay. And then from the gambling problems, we check the attitude toward risk. And then I will introduce you with the utility and utility function. Okay. And then the expected utility. And we will discuss about risk premium and certainty equivalent. Okay. So to show you the big picture, so we are now in the fourth part of the series, right? So this is decision analysis. We are in the decision under utility. Okay. Okay. So let's discuss first. Okay. You already learned decision under risk, right? So suppose you have two choices. Okay. Option A, you're guaranteed to be to get the payoff of $60,000. In option B, okay, there's 50-50 chance. Okay, 50% chance you gain 150, okay, 150,000, and 50% chance you will lose. You will get a loss of 30,000. So the question to you is, which option you will prefer? And then why? Okay, if you calculate, can you calculate the expected value? The expected value of option B is what? The expected value of option B is 0.5, right? Multiply by 150. Okay, the 1,000 I will remove. My handwriting is so bad. 150, okay, plus 0.5 multiply by 30. How much is this? It is exactly
90.
Oh, sorry. This is negative because this is a loss.
Oh,
Right.
oh yeah, right.
So this is 75 minus
60.
15, 60. 60,000.
Yes.
So exactly the same, right? So they have exactly the same expected value. So how are you going to do?
It's still better to pick A
For you.
compared to B.
Okay. For you.
Because there's still the chance of loss in B, while in A you don't have any chance of losing anything.
Yes. How about you, Livy? Which one you choose, A or B?
I would say option B.
Oh, why?
Because we still have the chance to gain like more.
Okay. So this is Livy is a risk taker. Okay. Joy is risk avoidance. Okay, in this case, in this example, comparing surety and gamble, which one you will choose? Okay, everyone have different preference, so there is no right or wrong. Okay, but everyone have different preference only. Okay, so perception is different. Okay, between 60,000 success and 30,000 failure, right? Or 60,000 success minus 160,000 success, right? So if you feel that X in here is greater than Y, then you will select A. Okay? So in this lesson here is actually you will learn how to quantify that kind of feeling, right? So, okay, let's discuss another gamble problem. Okay, let's call this gamble A and gamble B. Okay, a while ago, shorting and gamble, Joy choose shorting, Livy choose gamble, right? Now we have both of them gamble. Okay, Joy, you cannot choose shorting. Okay, but look at the probability. Okay, gamble A, you will win 100,000 with probability only 1%. And you will win nothing with a probability of 99%. Gamble B, you will only win 2,000. But the probability is half. And then you will win nothing, the probability of half also. Okay. Now, which one you will choose? Gamble A or B? Joy.
B.
B, okay. How about you, Livy?
Wait, sir. I might choose A
Oh, you will choose A.
because 0.01 is
1%. Smaller than
yeah,
99%, which will
but it's 10 out of 1,000, so it's still like a feasible thing with a very big number. I don't know.
Okay, no problem. So you will still choose A. How about you, Livy?
Yeah, I would say I will just gamble A.
You will choose
A.
A also. Okay. So for a two gamble problem, okay, because the probability is not that high, you will say, okay, both of you will or not, the probability of winning is not that low, probably. Okay, losing is not that high for you, so you will choose, both of you choose A. Okay, no problem. That is preference, right? So, can you throw the decision tree of the two gambles problem here? Can you throw the decision tree of two gamble problem? So, what are the alternative? Gamble A, gamble B. Okay. So once you draw the decision tree, okay, on paper or on the whiteboard, and then you calculate the expected value, and then what is your decision based on maximum EV? Can you do that?
Yes, decision tree, right? Do we need to make the payoff matrix?
Yes, it's already there. Okay, you can make payoff matrix or directly draw decision tree. That's fine also. You draw the decision tree. It is quite interesting. The two of them involve gamble, right? Gamble A, gamble B. Possible to draw the decision tree.
Okay, do I share my screen, sir?
Okay, please. Yes.
Okay, this is the decision tree. So gamble A, we have win and lose, 1% and 99%. This is the win if this is how much we win. Is it correct? Yeah.
The lose is,
Then
I don't think it's correct, the lose. 99%. I think,
oh, that's why. Yeah.
okay, good. Then 100 and 0. Is that correct? 1,000. Oh, the same. The same EV. Oh.
Yeah.
Yes. Yes. Very good. Very good. Okay, so, Livi, can you make the decision tree?
Leafy is gone, sir.
Oh, oh,
He got disconnected, I think.
I think. Anyway, she can follow the recording later. I posted in Lentera, there is a software add-ins for Excel for simple decision tree. I think it's free. If you want, you can also use that. It's an open source, and I tried, but not fully working. Okay, so where is the utility theory? Okay, so here it is. We have similar to yours. Okay, so we have gamble A and gamble B, right? And then we have winning and losing with different probability. Okay? And then you calculate the expected value. They are the same, right? So 1,000. Okay, so the expected value of the two gambles are the same. So using maximum EV alone, you cannot decide, right? So now, if you must decide which one you prefer, a while ago, you prefer A, gamble 1, right? Number. Now, this, if you select gamble A, okay, why? Because the price is higher than gamble B, right? Okay. But the probability is actually small, then you are actually risk lover. Okay. And if you choose gamble B, okay, you are risk averse. Okay. So again, similar to decision under uncertainty. Okay. This one, this technique to select the gamble will tell you what type of decision maker are you. So again, there is no right and wrong. It's just a type of decision maker only. Okay, so based on the attitude toward the risk, we can divide into 3 types of decision maker, right? Risk averse, risk neutral, and risk taker. Okay, so what is risk averse? Risk averse will prefer short things to gamble. Like in the beginning, I asked, comparing shorting and gamble, which one you will select? You said, okay, I will select shorting. Okay, that is risk averse, right? And then if the 2 alternatives are gambles with equal EV, okay, you will prefer safer gamble. Okay, so in your case, Joy, in the beginning you risk averse, and then for certain decision, suddenly you change, become risk taker. Okay, that's fine. Okay, that is based on utility. Okay, then later on we will try to quantify your utility. Okay, so risk averse is also if you have one gamble which has higher EV than the others, of course you will select the gamble with lower EV. If it is appear risky. Okay, so risk neutral is indifferent between shorting and gamble, so it cannot decide, okay, or just decide by the lucky chance. So if all alternatives are gumbels with equal EV, okay, then again indifferent. Okay. Now, if one gumbel has higher EV than the others, of course, we'll select higher EV. Now, the characteristic of risk taker, okay, is prefer gumbel to short things, and if the two alternative or all alternative are gumbels with equal EV, it will prefer riskier gumbel. Okay. And if one gumbel have higher EV than the others, it will select gumbel with higher EV. So these are the characteristic of risk taker, risk neutral, and risk averse. Okay. Now, utility theory is an approach, okay, to assess the risk attitude quantitatively. Okay, so you will try to quantify, okay, your own relative preference for a particular outcome. So here is the practice. Okay? Here is the practice. So utility is measure of total worth of a particular outcome. Okay. So for example, okay, if you know the minimum and the maximum, say the minimum is negative 500, mean losing money, okay, for a certain problem, and then the maximum is positive 2000. This is just an example, and then you can put any number here in between, okay, either consecutively or not consecutively, that's fine. Say I have $2,000 as maximum, minimum is negative 500, okay, and then I will fill up the payoff of X. Okay. The minimum will get 0, the maximum will get 1. Now utility, you can fill up any value which is monotonically increasing between 0 to 1. Can you get it or not? So for example here, if I get minus 500, I will fill up with 0. This is your opinion, okay? And if I lost 100, so I will choose 5%. Okay? 0 mean I will put 10%. Okay? If I gain 100, that is 50% already. Okay? And so on. So you fill up this utility so that you can start to throw. So I want you to practice right now is this. Suppose you have certain gumbel, okay, or similar like this, yeah, gumbel 1 or gumbel 2, which is gumbel A and gumbel B like this, okay, and then this is your payoff, okay. Can you start to feel the value between 0 to 1? Is it possible or not? So you create utility of certain payoff, okay, and then you start to create the value for that. Can you practice to create this? So let's take example. Minimum is negative 500, maximum is 2000. How do you feel your utility? Based on your payoff. Okay. One payoff is negative, two positive. Can you actually create your own utility value? Can you share your screen? Do you understand the instruction or not?
I'm a bit lost. I can just share my screen and you can guide
Okay,
me
okay.
through
I
it.
will guide you. Okay. Okay, so say from 2000, yeah, and then you can make it smaller and smaller. Okay, up to -500. Okay. Now, if 2000 you put 1, that is your utility. Okay, and then if -500 you put 0. Now you can fill up in between with any number as long as monotonically increasing. That means 500 must be larger than 0, right? 1000 must be larger than 500. So you can fill up anything. And then you evaluate your own feeling. Okay. You know that if you lost $500, okay, you feel bad. That is 0, right? So you know if you get $2,000, okay, you feel very good. That is 100%. Okay. Now you evaluate your own feeling and then you fill up these values. Any number is okay.
Okay. Too high, too high. Wait, maybe I should
Yeah,
add
you can.
more.
Okay, you can. No need to be in the same
Intervals.
interval. Okay, so you can make it different interval. That's fine.
So the utilities is like my satisfaction.
Your own
later.
satisfaction. Yes. Okay. The most important characteristic is monotonically increasing from 0 to 1. This is interesting. Okay, I can see here that you put exactly the same value, 0.05, right? For
Yeah.
so okay, no problem. This is mean you are not so strict in your utility. So now you can chart this payoff and utility. Okay, the payoff is X, the utility is Y. You can chart. Okay. Okay.
With
I think scatter plot is fine. Scatter plot. Okay, with the line, Okay. So I can see the line.
I think this gap is
Okay, you can move.
Oh no.
Move all and then go there. Okay. Okay, that one. Oh, good. Now you can see your own chart. Okay, utility chart. Okay, the horizontal axis is your payoff, and then the vertical axis is your utility. Interesting. Okay. Later I will discuss what's the meaning of that chart, right? Okay, I want to see Livy. Can you make the same thing? Okay, but based on your own feeling. So this is how you quantify your own feeling. Okay, satisfaction. Of course, it will be different satisfaction for different things, right? For example, for food will be different for computer, for example, right? Your utility theory, your utility function will be totally different. It's fine. For each cases, you will start to draw your own utility value. Okay, so this is just an example. Livy, can you make it? Can you share your screen? I think. Okay, Livy, you want to share your screen?
Oh, um, yeah, here.
Okay, so can you plot now?
Uh,
The payoff and the utility. Insert and then scatter plot. Okay, with the line. With the line. Okay. Oh. Okay. Okay, that tells something. Okay. Okay, so what's the meaning, right? Okay, I will share my screen now. So, okay, come back. So let's say if you don't know, if you don't want to draw manually like that, okay, you can use this function. Okay, so depending on what type of decision maker are you, okay, risk averse, usually we can use polynomial function or exponent, okay, or if you are risk taker, you can use this function of quadratic for polynomial, and for the exponent is the again, this is the formula. Okay, so most people are risk averse. Okay? Most people. Okay? Most does not mean all, right? So most people are risk averse. That's why the one in yellow is the one that I suggested for you to use. Okay, so exponential risk averse. That is the one that we will use. Okay, so when I plot this function, okay, so you will see, okay, using polynomial, okay, the purple line here is the square, x square, and then the, x square root, yeah? And then the green line is the x square, right? So risk taker, the green line is the risk taker, and then the purple line is the risk averse. Now, from the shape of the utility function, you will know whether it is risk taker or risk averse. How do you know? The curvature, you see here. Okay. So if I use the polynomial utility function, the nice thing is I can normalize between 0 to 1. Okay, I don't need any parameter. Okay, but the problem is it's only used from 0 to 1, yeah? The x value. So the cost cannot be put there. So that's why usually I use exponential value. Okay, so how do you know that this is actually risk averse or risk neutral? Okay, so you can check based on the concave or convex. Okay, so risk averse is concave. Look at the curve is going on above the straight line. Okay, and risk taker is below the straight line. Okay, and risk neutral is exactly straight line. Oh, okay. Now, based on your plot a while ago. Okay, so say this is my plot for myself. For example, I will have like this. This is my personal utility. So you see here, okay, what is this? In negative region, in this example, I will have what? Risk taker. Yeah? If I'm losing, I become risk taker. Okay, but if I'm gaining, I will become risk averse. So this is the example. So now you evaluate your own chart a while ago. Are you risk taker or risk based on the concavity or the convexity of your chart? Then you can check. Oh, you want to share your screen again and then tell me.
Sure, I can share mine.
Yes.
Mine actually looks like quite straight line almost. But then
Yeah, in the beginning, say from 500 to 500, negative 500 to positive 500. What is this? Yeah, not enough data, so it's kind of straight line. Okay, and then from 500 to 2000 is a kind of risk taker, isn't it?
yes.
Yeah. From for positive, if the gain is a lot, you're kind of risk taker. Okay, but overall, the overall curve is actually can be seen as risk avoidance. But only when the gain is big, you suddenly become risk taker. Okay,
Yes.
this is just interpreting this graph. Okay.
Yeah.
Okay. So it's true or not, I don't know. Okay, I'm just interpreting this graph based on
Yeah, but it's kind of true. when the gain is really big, I become risk taker.
So this is the interpreting of the graph. Okay, so again, can you show Livy your own chart? Maybe we can start to interpret. So suddenly we become wizard. Can interpret the feeling of one person. Oh, so again, if from negative 500 to 500 is like a risk neutral, okay, straight line, right? And then from 500 to 2000 suddenly become risk taker. Oh, Livy is risk taker. Yeah, if the gain is big, again you become a very. Actually, the curve is very big. That means you are more risk taker than joy. So I'm just interpreting based on the slope. Okay. Okay. Just don't take it seriously. Okay. But at least this is the way to interpret. Okay. So let's take a lunch for a while and then come back again at 1 o'clock.
Okay, see you there.
Yeah.
Sir, I cannot hear your voice.
Oh, can you hear my voice? No?
Yeah.
Okay, good. This is what we discussed the last time before lunch, right? So we can check the type of decision maker, okay? Whether you are risk taker, neutral, or risk averse, okay? Based on the concavity or the convexity of the utility function, yeah? So if the shape is something like this, right? On the top of a straight line, so this is risk averse, yeah? So how do you know? You can take the second derivative, okay? So the second derivative is negative, okay? And then risk averse is concave, that means the second derivative negative. Risk taker is convex. Okay, risk taker is convex, so the second derivative is positive. Okay, and risk neutral is linear, that means the second derivative is 0. Yeah, straight line. Okay, so with that, we discussed that you have a possibility that up to certain value you are a risk taker, and for other certain value you are risk averse, and so on. So okay, next, this is the most used utility function, which is exponential utility function, right? And why we use the risk averse to neutral? Because most people are basically risk averse. Okay, so the real function of utility function supposed to be like this. Can be positive, can be negative in terms of the second derivative. But if you want to approach theoretically, okay, this is one of the method that widely used. Okay, so where this come from? From this earlier table. Now here. Okay, so we have 4 proposal for a utility function, either polynomial or exponential, and then whether you are risk averse or risk taker. Okay, so the one that I propose here is the exponential, meaning this is for risk averse. Okay, now come back here. So if you use this, okay, so utility function of x is the payoff, right? And then y is equal to 1 minus exponent of minus x divided by r. Okay, r here is called risk tolerance, yeah, or a shape parameter in this case. So if r is 0.5, you can see the top figure here. Okay. Okay, this one, right? And then if r is 1, this is the value. Can you see it? And then if r is 2, becoming almost straight line, and the larger r is becoming smaller and smaller, the gradient, yeah, the gradient is becoming smaller. Okay, eventually it will become risk neutral, yeah. If the r is very big, it will become risk neutral. Okay, so now I want to know, okay, so if you have a data, then you ask, oh, how I will define this parameter r. Okay, so how I will going to calibrate my model of utility function. Okay, how I will get the value of r, say parameter or the risk tolerance. Yeah? Okay, I will give you example. Okay, so suppose you have a lottery to assess r. Okay, if you win, okay, your payoff is 8. Okay, the probability is 0.5, and then if you lose, the payoff is L, probability is again, for example, 0.5, and then you compare in the left hand side you have a utility of a gamble, okay, with 2 outcomes, with this win or loss, and then on the right side is utility of certainty. Okay, so this is between shorting and gamble. Okay, that is how you define the risk tolerance. Okay, so because we know the probability is 0.5, so we put 0.5 here of the utility of lose. Okay, L is lose in here, plus 0.5 times utility of 8 in here is the win payoff. Okay, this must be equal to the utility of the certainty. Yeah? C is the winning of certainty. Okay, and then how do you get the UL here? UL is based on this function, right? 1 minus E exponent minus x per r. R we don't know, so we want to know. Okay, so then we just input this formula of utility into this equation, yeah. So we put because 1 minus 1 is the same, so we can just put the exponent here, right? So you get what? Exponent of h divided by r plus exponent of L divided by r equal to 2 of exponent of C per r, okay? So because h is a number, L is number, and C is number, so then you can get the r, right? Either you take the ln or you can use Colesig in Excel. So take example. Okay, so suppose h is 1, L is 0, C is 0.5, and probability is 0.5, like a while ago. Okay, so you input h1, L is 0, C is 0.5, right? And then you calculate the left-hand side and the right-hand side. And then the target here is the difference between the left-hand side and the right-hand side. And then you use Colesig to get the risk tolerance. Okay, let's practice this. Yeah? So I will show Excel. Okay, so you have what? You have H, you have L, you have C. How much is the H? 1, right? L is 0, suppose. And this one supposed to be 0.5. The probability 0.5, right? Then 0.5. What is the probability of C? Livy, Joy, what is the probability of C?
0.
Why 0? This 2 is for Campbell. This C means certainty. You want to compare between Campbell and certainty. So the probability of certainty is
1.
yes, 1. Okay. It's just certainty, so probability must be 1, right? Okay, so then you calculate the utility, yeah? Utility. So what is the formula? Oh, depends on R, right? So then I will put R here. Okay, this is, you can put any value first. Yes, I put 1. Okay, so put value 1, and this is the one that we input, right? So what is the value of the utility? Equal to 1 minus exponent, correct? Minus of x, this is the x, divided by the r. Is that correct? And then, okay, you multiply by, so utility multiply by probability. Right, so this is the x. The x is the payoff. Okay, so how much is this? This is exactly the same thing. So I will copy. So I put to copy. I need to put dollar string here. So I copy. Okay, and then how much is the utility? It's just utility multiplied by the probability here. So I got, right? So now I need to get the left-hand side. Okay, so the left hand side and the right hand side. The left hand side is the combo. So in that case, I multiply a plus. Yeah, this one plus this one. Right. The right hand side is just copy of this. Okay, now I get the difference. Right. So what is the difference? Just minus. Yeah? Left hand side minus the right hand side. Okay. So what I will do, I will go to the data. What if analysis goal seek? What do you want to set? I want to set the difference to 0, right? Between left hand side and right hand side by changing the R. Okay. Da-da-da. Oh, I got 14. Yeah? So this is the answer. Oh, not yet 0. I need to set again. This set to 0 by changing cell. This one. Where is the option? There is no option. So, yeah, almost. So it's about the R is about 14 in this case. So can you make it? Make it. Is this clear or not? Okay, so if it is clear, I will give you a test. Okay, so here is the test. Keep this short. I'll give you the test. Oh, can you find the risk tolerance of exponential utility function? Okay, first, right? Based on the following data. So the win payoff is 1,000, probability is 0.25. And then the lose payoff is negative 500, probability is 0.75. Okay. And then the payoff is positive 250. Okay. It is indifferent between playing lottery and certainty. Okay. So because we are using exponential value, so you need to set so that the value is between 0 and 1, the x. So you divide, in this case, the larger is 1,000, so you divide by 1,000 all. Okay. So what is the R? Can you get it? Once you finish, you share your screen. Is it done? Do you have difficulty? Oh, where is joy? Disappear.
Sir, for the right hand side and left hand side, what is the number? I mean, like, can you show me the previous Excel?
Sure.
I forgot.
Is this the one?
Oh yeah. Okay. Wait. Oh, the utility.
Yeah, they are very close.
The formula for the utility at C is the same, right?
At C is the same. Yeah.
Yeah, it's the same.
1 minus, is that correct? Is this formula correct? 1 minus exponent of x divided by r.
X divided by, yeah.
Yeah. Yeah, correct. 1 minus x exponent x divided by r. Correct. How about in your case?
Wait. Here is this one. This one. This one.
Pause. Oh, okay. So it will not work for the second case. You know why? Because the value is very big. Okay, 1,500. Okay, and you are using exponential function. Okay, so in that case, you need to scale. Why you can scale? Because utility is an ordinal value. Okay, is monotonic increasing or decreasing, but the actual value is not so important. The order is important. Okay, so in that case, you scale it down. For example, instead of 1,000, you divide by 1,000, so become 1. And then now negative 500 now become divided by 1,000, so that one becomes negative 0.5, and then again the 250 divided by 1,000, so 0.25. Yes, okay, now you can use. Okay, again the same, just use data and then what if analysis, Colesic. Yeah? You said the difference. No, the difference to be 0. Oh, it's already 0.
Yeah, it's already 0.
Oh, okay. So by luck, you got okay. R is 1, so you got already 0. Is that correct? Yeah. Okay.
Yeah, it's 0.
Hmm? Whatever value is 0. Are you sure it's correct? That's strange. Oh, something is wrong. What is the? Okay. Can I see the utility? The exponent is correct, and then the next one, column E. Can you go to column E13? Okay, T times C, correct. How about B14, A17, B17? Oh, plus, you need to plus. This one is E13 plus E14.
Oh.
E14 plus. Yes, correct. And then the left-hand side is the E15, right? Okay, correct. Okay, now you can use again the data, what if analysis. That's correct, yeah.
Okay, so
You can put any value R, is no problem. And then now we search, okay. Colesic, the difference set to 0 by changing the R. Right, okay. What is the value of R? Oh, very big, huh? About 400, right? About 400 something. Okay, so big value of R mean they are actually almost risk neutral. Right? Okay, so clear?
Yeah.
Yeah, very good. Joy, can you follow? You just come back. We are finding the parameter of risk tolerance. Okay. So we do have this utility function, right? So, and this utility function contain the parameter R, okay, of the shape parameter or risk tolerance. So now given the data, we want to find out what is R. Okay, so you need to know the payoff and the probability, okay, of the Campbell versus certainty. Okay. So Campbell versus certainty. So if probability is 0.5, 0.5, then you use this formula. Okay. Now, because utility L is given by this formula, so you just input. Yeah? So now
using this new formula, the only things that you don't know is R, right? So you can use Kolsik to get the R, or you can derive using ln. Livy, you can derive using ln if you want. Right? It's just logarithmic of this. Yeah. Okay, so using Excel, you just use Kolsik, then you can find the R. Same thing with this. Okay, so if in this example, I give you 1 and 0 and 0.5, it's, the probability is exactly 0.5, so easy. Okay, and later on, I said, okay, what will happen if we change the value? Okay, so the real value is say 1,000. Okay. And 500 like that, right? Especially if you are in Indonesian, so you are using rupiah, the number of zero is so big. Right? So if you use exponential function, okay, don't use the actual value, but you need to rescale it, yeah, between 0 and 1. So this tip is really very useful. Okay, so the absolute value of x is between 0 and 1, yeah. Oh, maybe I don't need this. So I just say less than 1 is enough, right? It's exactly the same between 0 and 1. Okay, so now in this practice 3 and 4, okay, you can try. Okay, in practice 3, the purpose of this practice is to show you what is called expected value of the utility of the expected value. Okay, so this is in here. I want to calculate the utility of the expected value. So UAV, right? In practice 4, I want you to calculate the utility, the expected utility value. Okay. So we used two Gumbel problem. Remember the two Gumbel problem earlier that we discussed earlier here, right? Gumbel A, Gumbel B. This is the probability, and this is the payoff. Okay. This is the two Gumbel problem. Okay. So try to use to practice now. For two Gumbel problem, can you calculate the utility of the expected value and the expected utility? Okay, so say in practice 3 here, I want you to calculate the utility of the expected value, okay, of the two Gumbel problem using polynomial utility function. Okay, for risk taker, for risk neutral, and for risk averse. So what is the polynomial utility function? Do you know? What is the polynomial utility function here? That is based on this table. Yeah. So polynomial utility function is, this is the risk averse and this is the risk taker. Oh, I know the risk averse and risk taker function for polynomial. How about the risk neutral? What is the function? What is the function polynomial for risk neutral? Joy?
Is it equal to the EV?
Yeah, ux equal to x. Okay, it's a linear function. Okay, it's a linear function, means ux equal to x. Yeah. So risk neutral for both polynomial and exponential is the same. So ux equal x. Okay. So let's do that. Okay, so in practice 3, so you know this gamble A and this is gamble B, this is the value. Okay, and try to compute. Okay, so if you use risk averse, okay, we use a square root of the value, the AV, which is 1000, right? So, and then if you use neutral, again, you get 1000. How about if you risk taker, you take quadratic, right? So, and the problem is you want to compare gamble A and gamble B, isn't it? These are the two alternatives, right? But if you use utility expected value, okay, this is exactly the same as EV, which is the same as expected value. So because earlier you cannot decide, then this is also you cannot decide. Okay, so if you use the utility of expected value that of something that you cannot decide using EV, whether you convert it to utility or not, it will not change. Correct? Because utility is just monotonic function. Okay. How about if I want to calculate the expected utility? Oh, what is expected utility, right? So this is what you will use actually, not the utility of expected value. What you will use is actually the expected utility, okay, EU, okay, not European Union, but expected utility in here, okay? So for each alternative, okay, you calculate the utility of the gain, multiply that by probability, okay? And then PK here, what is this PK? K, what is K in here? How about this G, okay, JK. This is the gain of J. J is the row, K is the column. So what does the row mean? The row is the alternative, right? The column is the state of nature. You remember? Okay, so then if we use PK, that means the probability of the state of nature. Yeah, because K here represent the state of nature. So, and then we sum, what we sum? This is the sum of K from 1 to N. That means for all state of nature. Okay, and then you get the UJ. So that is the expected utility for alternative J, right? And then you take the argmax. So this is similar to under risk, yeah, decision under risk, but now you convert first, okay? Instead of using gain, you convert to utility first. Okay. So, okay, let's practice. Okay, can you do that? This time you use a polynomial utility function. Can you practice this? Which one is polynomial utility function? Come back to this table again. Here. Okay, so can you solve expected utility using polynomial utility function for risk averse, risk taker, and risk neutral? Practice, yeah.
But with the
Yes, you use two Campbell problem. Okay, two Campbell problem, and then you use a polynomial utility function, and then you calculate the decision based on maximizing expected utility. So what is expected utility is using this formula.
Oh, okay.
Okay. So okay, the output is decision. Okay, decision for a risk taker, for risk neutral, and risk averse. The output.
On my screen.
Can you share your screen?
So we calculate for each one, right? We have the
We have the so for Campbell A, you get risk taker is
10,000.
10,000. How do you get the 10,000? Square root. This is risk taker. Risk taker supposed to be.
Oh, I don't square it.
Yeah, you don't need to square. Right, right. So, and then risk neutral. Risk neutral, you don't know, so it's indifferent. So we cannot decide, right? And then for risk averse, okay, risk averse is correct. So number B. And this represent the reality. Yeah, this actually represent the reality. So if you are risk taker, of course, you will choose Campbell A, right?
Yes.
Yes, because the a small probability, but high risk, high reward. Yeah? So, and then risk averse, you will choose Campbell B. Yeah, that's correct. Yeah. Very good choice. Yeah. How about Livy? Is it finished? So, yes, you want to share? Okay. Okay, read first you get. Okay, very good. And then you just need to get the decision, yeah, with this the maximum utility, okay, expected utility. So the same as above. So in this case, what is the maximum? 22, right? Between 3.16 and 22.3. So the answer is B in that case, right? The decision is B. And then for a risk taker, which one is bigger, A or B?
A.
A. Huh? And then this one, what is the decision?
Cannot decide.
Cannot decide. Very good. Yeah. Okay, so that is the technique, the same thing as risk, okay, but you convert it to utility first. No, my question to you, what is utility? In your own word, what is utility? So we discussed utility from early morning until now, what is utility? Is this a real thing or just a concept? Okay, when you said risk is clear, right? It's a probability, right? Okay, and now suddenly you have a new concept called utility. Okay, so utility itself is just a number, right? Which is basically an ordinal number, which had characteristic of monotonically increasing. Okay, the actual value is not important. Okay, so what is utility represent? Represent your satisfaction, represent your preference, right? Represent something about your own feeling. Just an ordinal number. Okay, so it's an index, represent something. What's something? Okay, if it is about preference, yes, it's that something is preference. If it is about satisfaction, then that something is about satisfaction. Okay, so utility is just an index to represent certain feelings, okay, certain perception, okay, based on ordinal number. Okay, this is not ratio, so there is no real units. Okay, it's just a concept. Okay, with this concept, suddenly you will be able to detect, right? Oh, I am a risk taker, or I am a risk neutral, or I am a risk averse, right? So, okay. So next practice, okay, is the first things, okay, between gamble and certainty. Okay, practice 5 is between gamble and certainty. Okay, so use, so we are given the shape factor, the risk tolerance is already given, which is 5. So use exponential utility function with shape factor 5, okay, to decide whether our earlier discussion based on expected utility, okay. So for option A, guarantee payoff of 60,000 K, right? Option B is 50-50 between gain 150 and losing 30. So the problem is similar, okay, but the utility function is different. Okay. So risk factor 5 using utility function. So what is this? Risk neutral, risk averse, or risk taker? Can anyone say? What is this? Which utility function? Hmm? What do you think? Okay, so when we discuss the utility function, we always use the risk averse. Okay. Okay, so we always use the one in yellow like this. Okay, so I said here most decision maker are risk averse to neutral, so that's why we'll use this. Okay, so try to do practice 5. Okay, using a risk factor, shape factor of 5. Okay, and the answer is already there anyway, so you can practice this on your own. Okay. Okay, so time is up. Thank you for today. Okay, so next meeting we discuss about risk premium and certainty equivalent. Okay, it's also in the same slide. So risk premium. Okay, thank you.
Okay.
Thank you, sir. See you next week.
See you next week.